Hello everyone, thank you for joining me. In this video we are going to write the equation of a piecewise function by analyzing its graph. So I can see right off the bat that this particular piecewise function has three pieces to it. So when I write my function, I'm going to do f of x equals, and I'll need three pieces, and I can actually just put the ifs in right now. Or you can use the word for, it doesn't make a difference. And now we will write the equation for each piece. Usually the easiest pieces to write the equations for are the horizontal lines, like this one right here. We just need to identify what y value that horizontal line is positioned at. It's positioned at the y value of 4, so the equation for that piece would just be y equals 4. But since over here in the equation we already have the f of x in there, we just have to write the 4. And that takes care of the first piece. Then we ask ourselves, between what two x values does that piece exist? Well, it exists between this x value and this x value. So that's going to be -9 and -3. So we smack an x in the middle, -9 here, -3 here. Now it might seem like your inequalities need to face two different directions, but these are actually also both going to be less thans. So we have -9 is less than x is less than -3. And then because we have a solid point right here at this end, we're going to put an equal to on the -3 part. And since this is a hollow point, we just leave the inequality next to the -9 as a strict less than inequality. All right, we're 1/3 of the way there. Let's look at the other pieces. Erase some of this mess here so it doesn't bother us. Okay, the next piece is line segment number 2 here. We'll do this one a slightly different way. Let's look at where it exists first of all. So look at the two x values. It's trapped in between, and we see that it's stuck in between -3 and +3. -3, +3. Both of these are going to be less thans. To put x in between them. We look at the hollow point here, which means we're going to keep just the less than at the -3 side. Solid point here, so we're going to change this into an equal to. X is less than or equal to +3. To write the equation of a line that's not a horizontal line, we just need to identify two things. What the slope of that line is, we need to find its slope, and we need to identify where the line hits the y-axis. That way we can write the equation in slope-intercept form. So we're trying to find an equation to form y equals mx plus b. Well, we can see right here that its y-intercept is just 0 because it crosses the y-axis at the origin. So it's going to be mx plus 0. We won't even bother to write the 0 in our final answer. And the slope can be found just by finding 2 points on the line and seeing what the rise and run is over between them. So check it out. Here's one point, and here's another point, and you can see that you're going up 2 over 1. It's going to be a slope of 2. So y equals 2x plus 0. So the equation of just that middle line there is going to be 2x. You could write 2x plus 0 if you want to remind yourself that y-intercept is 0, but 2x is sufficient. Okay, we're 2/3 of the way there. Now we will look at the final part. Once again, I'm going to clear the mess up over here on the graph. You can always rewind it though if you need to see it longer. All right, this last one, let's find out where we are. Looks like we're starting at 3, but this one, since it has the arrow on the end, goes off to infinity on the x-axis. It just keeps going to the right forever. So what we want is we want to say 3 bigger than 3, but we don't want to include the 3 because of the hollow point there. Now we actually don't use the infinity symbol when we do inequalities, so this one's going to look a little bit different. It's just going to be x is greater than 3. If there was a solid point there, we would say x is greater than or equal to 3, but there's a hollow point right here, so we just go greater than 3, and since we keep on going forever and ever to the right because of the arrow, then we don't put an upper bound on it. We just say x is greater than 3. Leave it alone. Okay, now I'm going to try and identify the slope of this line. Looks like we got a point right there and a point right there, so we're going down 3 over 1. So the slope of this line is going to be negative 3, the equation is negative 3x plus b. But we still need to identify what the y-intercept is. As you can see though, the problem is this particular line that we're looking at, or piece of a line here, we don't actually see the place where it hits the y-axis. So we got to use our imaginations a little bit here and check this out. If its slope is negative 3, that means we can kind of backtrack it to the y-axis and see where it would hit the y-axis if it was allowed to keep going. So check this out. Up 3 over 1, because when I'm going the other way, I'm going down 3 over 1. Up 3 over 1. Up 3. Oh my gosh, I'm off the graph here, but I can tell that I went 2 above, so it would actually hit at 12. So this is going to be y equals negative 3x plus 12. Negative 3x plus 12. And of course, if any part of that video went too fast for you, you can go back, rewind it, watch it again. But this is a completed answer, and this is the equation for the piecewise function we see over here. Let's clean it up so you can see it all together. And we're done. You can watch another one if you're still struggling. Thanks for watching.